Welcome to this online revision session for AQA FP4. This time we're covering January 2010 question 5 on matrices and transformations. We can see we're given two transformations represented by the matrices A and B. And there's three parts to the question, and we'll just go through each part in turn. So, first part of this question asks us to find the equation of the line which is the image of y equals 2x plus 1 under the transformation TA. So we've got to apply the matrix 3, negative 1, negative 5, 2 to this line. So if we do that, what we're going to get, remember the matrix goes in front of the coordinates on that line. So to describe a coordinate on that line, if its x value is little x, then its y value is given by 2x plus 1. And so when we multiply these together, we're going to get row times column, 3 times x, negative 1 times the 2x plus 1. Which is going to give us 3x minus 2x minus 1, so that is going to give us x minus 1. And then the second row by that column gives us minus 5x plus 4x plus 2, so that will give us minus x plus 2. So those are the image coordinates, and those are our new coordinates for the image. So the new coordinates we can think of as being big X and big Y. And so now we want to eliminate the little x to get a relationship between big X and big Y. So if big X is equal to x minus 1, that tells us that little x is equal to big X plus 1, and then if we substitute that in for the fact that big Y is equal to minus x plus 1, that is going to give us minus big X plus 1 plus 2, which therefore gives us the line Y equals 1 minus x. So this is our image line. So the line y equals 2x plus 1 is mapped onto the line y equals 1 minus x. Okay, so we've got 3 marks here. So firstly a method mark for finding the image, and an accuracy mark for getting the correct image point, and then for playing around with this to give us the correct equation of the line, we get an accuracy mark for that one at the end there. So there are our 3 marks for that first part. Okay, then part B. Well, in part B, what are we told? We're told that the rectangle PQRS has an area of 4.5, and it's transformed into this new parallelogram P-Q-R-S- under the transformation of TB, and we have to find the area of this image. Well, we know that to determine the area scale factor, we need to know the determinant of B. So that's the first thing we need to work out. So the determinant of B is going to be 2 times 13 minus 5 times 5. So that's 26 minus 25, which is equal to 1. So that is telling us that the area scale factor is 1, which means that the area is not being changed, So in other words, the area of the image is also 1. And so if that's the case, we can write down the fact that the area of P dashed, Q dashed, R dashed, S dashed must be equal to 4.5, the same as the original. Okay, so if that's the case, well, it's fairly straightforward, using the fact that at some point you've used the determinant of that matrix in order to find the result. I'll give you a method mark and obviously an accuracy mark for getting the correct answer for that area. Finally, moving on to part C, we've got to find the single transformation TC, which is the composition of TB followed by TA. So we've got to find the matrix and then describe the transformation. Key thing is then, if it's TB followed by TA, then that must mean that matrix A goes in front of matrix B. Okay, so that's the first key thing, is getting those matrices the right way around. So we've then got the 3, -5, -1, 2, and B is the matrix 2, 5, 5, 13. So now we've got to multiply those together. Okay, so again, it's row times column, so it's 3, -1 times 2, 5, so that's 2 3s are 6 minus the 1 times the 5, so that gives us 1. Second row by the same column, it's 2 times -5 and 2 times 5, which is going to give us 0. Then the top row with the second column is 3 5s are 15 minus 13, which gives us 2. And then finally, it's the -5 times the 5 and the 2 times the 13, which again is going to give us 1. So that gives us the matrix which represents this transformation. Okay, then we've got to describe TC, this transformation. Key thing is then, we should recognise that this is the typical matrix form of a shear. To be a shear, there must be a line which is fixed, and that line is given, as we can see, the image of the base vector I is 1, 0, so it is I, so that means that the x-axis is fixed, so the shear is parallel to the x-axis. Then the other key thing we've got to indicate is, if everything is moving parallel to the x-axis, we need to give at least the image of one point. Any point will do. So if we take the point 1, 1, for example, and multiply it by the matrix 1, 0, 2, 1, we're going to end up with that being mapped onto, transformed into the point, well, 1 times 1 and 1 times 2 gives us 3, and the 1 times the 0 and the 1 times the 1 is just giving us 1. So that's the key thing. Remember, with the shear, we need to say the motion is parallel to a fixed line, or a fixed set of points on that line as well, and give the image of at least one point as it moves parallel to that line. So again, this part we get 5 marks. So we need to be attempting the correct calculation to start off with to get 1 mark, and get an answer mark for the correct matrix. Identifying that it's a shear will give you a mark. Then giving it a full description by firstly stating the fact that it's parallel to a particular fixed line, and then stating clearly an image of a point, not necessarily 1, 1, but at least a point under that transformation. And that gives you your final fifth mark. Hopefully you found that solution helpful. For more support for your revision, please go to the Further Maths Support Programme website.